On to page 2. Number 5. Find the value of the variable x if m is parallel to n. Measure of angle 1 is 2x plus 44, and the measure of angle 6 is 5x plus 38. The diagram is not to scale. So we'll start by labeling what we know. We know that m is parallel to L. That's important because otherwise we couldn't draw any comparisons between these angles up here and these angles in the second intersection. If measure of angle 1 is 2x plus 44, so let's label that 2x plus 44. Measure of angle 6 is 5x plus 38. So let's see, 5x plus 38. Now we think about how these two angles are related. Are they congruent? Well, let's see. They don't even look congruent. And they're not corresponding angles or alternate interior angles or alternate exterior angles, so definitely not going to be congruent. Well, what else then? Well, angle 1 and angle 5 are congruent, but angle 5 and angle 6 are supplementary. Remember, they add up to 180 degrees, which means that angle 1 and angle 6 are supplementary. When you have two parallel lines, any two angles between 1, 2, 3, 4, and 5, 6, 7, 8 are either congruent or supplementary. So it's not too hard to figure out which one they are. In this case, they're supplementary and they add up to 180 degrees. So I can just write 2x plus 44 plus 5x plus 38 equals 180 degrees. Now to solve the equation. Combining like terms gives me 7x plus, let's see, 44 plus 38 yields 82 equals 180 degrees. We subtract 82 from both sides, and we're left with 7x equals, let's see, 98 should be. And then we divide both sides by 7, and 98 divided by 7 gives us 14. So x equals 14. And that, double check the directions, find the value of the variable x, that's what we're supposed to find. It's important to check the directions because sometimes it'll ask you to find something other than x. But in this case, we're good. 6. Fill in all 8 angles if the measure of angle 4 is 68 degrees and the two lines are parallel. So, let's see. Measure of angle 4 is 68 degrees. And we know that angle 1 is a vertical angle, so it's also 68 degrees. We know that angle 5 is corresponding to angle 1, so that is also 68 degrees. And angle 8 will be vertical to angle 5, so also 68 degrees. What about the other angles? Well, the other angles are going to be supplementary to 68 degrees. So all I have to do is do 68 degrees, okay, and subtract that from 180 degrees. So 180 minus 68 gives us 112 degrees. So all these other ones are going to be 112 degrees. Alright, what is the relationship between angle 1 and angle 5? Well, here's 1, there's 5. Angle 1 and angle 5 are corresponding angles. We know they're corresponding because they're on the same position, the kind of the top left of both of these intersections. So they are corresponding angles. Between 4 and 5, let's see, angle 4 and angle 5. So we're talking here and here. Okay, those two are on the interior of those two parallel lines, and they're on alternate sides of the transversal. So these are alternate interior angles. What is the relationship between angle 2 and angle 8? So here's 2, here's 8. Now they're both on the exterior, the outside of the two parallel lines, and they're on the same side of the transversal. Remember, the transversal is this line right here. So these are same side exterior angles. Question 7. Name all the angles that are 75 degrees. Write a short explanation for why you were able to label the angles you did. Use appropriate theorems in your explanation. For example, same side interior angle theorem, isosceles triangle theorem. What I'm going to do here is, instead of writing out an explanation, I'm going to draw arrows from one angle to the next, all the 75-degree angles, and as I draw that arrow, I'm going to write down why I know that those are both 75 degrees, why I know they're congruent. So I'll start this way. If this angle is 75 degrees, I know that this angle right here is also 75 degrees. Why is that? Well, actually, let's just take a look at some of these markings first. We see that we've got these are congruent, which means that this is an isosceles triangle. These are congruent, another isosceles triangle. These are congruent, another isosceles triangle, and we've got these two parallel lines. That's going to be very important. For this first one, we use the isosceles triangle. This is 75. This is also 75 because the angles across from the congruent sides in an isosceles triangle are themselves congruent. This is called the base angle theorem, or the isosceles triangle theorem. So, all right, base angle theorem. What else? Well, if this is 75 degrees, will also be 75 degrees right here. That's because they are vertical angles. If this is 75 degrees, this will also be 75 degrees. Again, we've got a smaller isosceles triangle right here. Also called a base angle theorem. Either of those work. We've got vertical angles here, so we've got 75 degrees is going to go there. Vertical angles. If this is 75 degrees, this over here is 75 degrees because we've got an isosceles triangle. Okay. What else? Well, actually, if this is 75 degrees right here, we've got these two parallel lines there and there. So these will be 75 degrees alternate interior angles. Okay. And if this is 75 degrees, this whole big triangle here, look at that. This whole big triangle is an isosceles triangle. See how this side is congruent to that side because of the markings. So this will also be 75 degrees over here, again because of the base angle theorem or the isosceles triangle theorem. So in general, we've used three big theorems here. The base angle theorem for isosceles triangles, vertical angles, and same side interior angle theorem because of the two parallel lines. If you'd like, you can write a longer explanation explaining the three theorems we just used. In all three theorems, remember, all three theorems say that the two angles are congruent. Vertical angles are congruent, alternate interior angles are congruent, base angles of an isosceles triangle are congruent. Number 8. If measure of angle BGY is 2x plus 1, and this is a typo in it, so make sure you fix this. Measure of angle KGM is x plus 61. What is the measure of angle KGM? What is the measure of angle KGY? Well, remember, this problem is going to be different from something like problem 5 before, because in problem 5 they're asking us to find a variable. In this one they're asking us to find the measure of an angle. Which means that once we're done with this, we'll have to do more than just solve an equation. We'll have to plug back in and make sense of the problem to find those angles. But to start, let's just write in the angles we know. Let's see. BGY is 2x plus 1. So BGY, 2x plus 1. And KGM is x plus 61. KGM is x plus 61. Alright, so how are those two related? Remember, in problem number 5, the two angles were supplementary. They added to 180 degrees. Now, if these two angles were right next to each other, a linear pair, adjacent, they shared a side, then they would also add up to 180 degrees. But that's not the case here. They're right across from each other, and they're vertical angles, which means that they are congruent. They're equal. So, 2x plus 1 equals x plus 61. Right? We can subtract x from both sides, and get x plus 1 equals 61. Subtract 1 from both sides, and have x equals 60. Alright, remember, they're asking for more than just what x equals. They're asking for the measure of KGM. So we look back here, and KGM, well, that's this x plus 61. So angle KGM equals, instead of x, we'll put 60. 60 plus 61, and that is going to be 121 degrees. What about the next one? Measure of angle KGY. Measure angle KGY. Let's see here. KGY is this angle right here. We know, because we just found out, that KGM, this angle right here, is 121 degrees. Notice that KGM and KGY are a linear pair, and they are supplementary. They add up to 180 degrees. So we could say whatever KGY is, we're going to have to add it to 121 degrees for kgm to equal 180. So if we subtract 121 from 180, we should have that angle KGY is 59 degrees.